right, welcome to class, everybody. I hope you guys are having a good Friday. So our lesson today is on section 3.2, which is about the slope of a line. So in yesterday's class, we talked about how the solutions to a two-variable equation can be represented with a line. So for example, if we had y equals x plus 1, there's an infinite number of solutions to that equation. Like for example, if we had x equals 0, y equals 1 would be a solution. So I could graph that at 0 on the x-axis and 1 on the y. Or I could say like maybe x is 2, which would mean that y would have to equal 3. And so the line that connects these two solutions also shows all of the other solutions to this equation. So that's what we talked about yesterday. And what we're going to talk about today is how you can describe the slope of the line, which is a number that describes how steep the line is. So for example, I have a whole bunch of different lines here. I don't know if you guys can see those very well, so I'll zoom in a bit. So on these lines, all of these lines have positive slopes, and the steepness of the line will be determined by the slope of the line will be determined by how steep it is. So for example, this purple line has a slope of 8, while this green line has a slope of 1. And we'll talk about how we calculate those numbers. But you can see that a slope of 8 means that it's really steep versus a slope of 1 is less steep. And you can have fractional slopes as well. Like you could have 1/5, which would be like approximately like about this steep-ish. That would be a slope of 1/5. So if you have a fractional slope, it's going to not be very steep at all. And if you have a slope of 0, that means that it's totally flat. And then negative slopes kind of work the same way, except that they go downhill. So you can see these positive slopes, like if you look at them from left to right, they're going up versus the negative slopes are going down. So on these ones as well, you'll have like bigger numbers if it's really steep and less big numbers if they're more shallow. So like this blue line has a slope of -1 versus, I don't know the exact numbers, but these will be like -5 or -6 or something kind of like that. So that's just kind of a general idea of what slope means and how we find it. So the way that we calculate slope is we basically compare the amount that the line is changing vertically to how it's changing horizontally. So this is often called rise over run. So the rise is how much it changes vertically. The run is how much it changes horizontally. And so to find this, let me move this so you guys can see it a little better. I don't know why the projector only shows like part of the screen, but there we go. So if we wanted to find the slope of this line, basically you're going to just choose 2 solutions on the line. So I would recommend choosing ones that don't involve fractions. So like this would be a good point to choose because you know it's -4 on the x and +5 on the y. You wouldn't want to choose a point like this one because you're like, oh, well, it's like in between -2 and -3 and in between 3 and 4. And it's kind of hard to tell exactly where it is. So I wouldn't want to choose a point like that, but I could choose maybe like this point. And so once you choose your 2 points, you're going to see how much it changes vertically and then horizontally. So I might say, okay, well, I go down 2 units. And so that means, that I have a rise of -2 because I'm going down 2. And then my run or my horizontal change is going to be a +2. And so the slope is going to kind of be a combination of those 2 numbers where we divide them. So in this case, it would be -2 divided by +2, which could be simplified to just equal -1. And we can see that that number matches what we would kind of expect it to be because we can see this is a downhill line, which means that it should be negative. And it's kind of steep, but not terribly steep. So a 1 seems like a reasonable number for that. Does that make sense kind of how that works? And it doesn't matter which points you choose, and it also doesn't matter which order you go in. Because like I could have chosen this point and this point, and I still would have got the same answer. Because I could say, well, I'm going to go down 5 So that'd be a run or a rise of -5. Then I'll go over +5. But when I divide -5 by +5, I still end up with -1. So you don't, it's not like you have to choose certain points. You can basically choose any points along the line. And you don't necessarily have to go left to right either. I usually tend to, that this is kind of like a habit of mine. But you could also maybe go like up 3 and then go backwards 3, which would give you, oh, sorry, you can't see those very well. Maybe I'll do it in red. So you could go like up 3 and then you could go backwards 3. But again, if you do a +3 divided by a -3, that still ends up equaling -1. So you can go between any points, any direction. You just need to, if you go up, it's positive, down is negative, left is negative, right is positive. So any questions on that so far? Okay. So let's practice finding the slope of this line. I'll zoom in so that you guys can see it a little better. So why don't you guys try this one on your own? And if you can't see it perfectly, just maybe estimate and your answer will be close to mine. So if I was going to solve this one, I might choose these 2 points that I've marked here. And if I chose those 2, my rise would be a +3 because I'm going up 3. My run would be a +1. And so the slope of that line is +3. And that's what we would expect it to be because it's an uphill line where it's going up from left to right. And the 3 tells me it's pretty steep, which we can see here that it is really steep. So that's how you can do that. Now, I didn't make a slide for this one, but what would the slope be if you had a line that looked like this? Yes, this one would be no slope because if you tried to calculate the slope on this one, maybe I could choose this point and this point. Well, that would be a rise of +4. So I'd have +4, but then I'm not going side to side at all. And so my run would be 0. But that's not a number because you can't divide by 0. And so this would be an example where the slope does not exist. And so like on your homework, if you get something like that, you would just say DNE because it doesn't exist. So if you have a perfectly flat slope, that will have a slope of 0 because, or a perfectly flat line that will have a slope of 0. Because on this one, it works because you could maybe choose like these 2 points and your rise would be 0 and then your run would be like +4. Or if you chose like other points, it might be like +7 or something like that, but it wouldn't end up mattering because 0 divided by any number will be 0. And so this type of line will have a slope of 0 because it's totally flat. If it's perfectly straight up and down, then it will have no slope or the slope doesn't exist. All right, so another way that you can find the slope is with this slope equation. So you may have seen this before. So essentially this equation is just like a formula for doing rise over run. Because if I had a point, let's say at 1, 2, and then maybe let's say 2, 6, I could calculate the rise over the run by saying, well, I'm going up. Well, I guess I should draw my line first. So I could go up 4 and then over 1. So my slope would be +4 over +1, which is just 4. So I could do rise over run, but another way that I can figure out these same numbers is if I take my y coordinate and subtract my other y coordinate. So like 6 minus 2 gives me this +4. And then if I do 2 minus 1, that's going to give me my run. Does that kind of make sense? So this is just like a formula version of rise over run. The most important thing here though is that whatever point you list first for your y coordinate, you also have to list it first for this one. Otherwise you might get your positives and negatives wrong. So you can use that slope equation if you'd like to. Do you guys want to see an example of that, or I can do it on this one really quick. So like in this case, it would look like the slope, which is represented with the letter M, equals 6 minus 2, because I take the two y coordinates and subtract them. And then that's going to be over 2 minus 1, because I take the two x coordinates and subtract them. And that ends up equaling 4 over 1, which equals the same slope I found by doing rise over run. So you have that. On your homework, you have some problems like this, where they'll give you an equation and ask you to graph the line and then find the slope of it. So there is a way that you can get the slope from the equation, but we haven't learned that yet. So on these types of problems, you can just use what we did yesterday to graph the line and then find the slope from there. So for example, on this one, I think it would be really easy to find the intercepts. So I'd say, well, if x is 0, what does y have to be? Yeah, it would have to be 6. So 6 is my y-intercept, because that's a solution to the equation. Then I could say if y is 0, what does x have to be? 4. So that would be my x-intercept. And so this is the line that equation this line represents all the solutions to this equation. And you already have 2 points on there. So you could just say, well, my rise is -6, my run is +4, and figure out your slope from there. Let's do a quick check-in on this. So on a scale of 1 to 5, how are you guys feeling about this? Okay, awesome. Sweet. So on your homework problem, there's one problem where it says solve for A if the line through these 2 points is given with this slope. So they give you a point and another point, but this point is missing a number. And then they'll like tell you what the slope is. So in this problem, it would probably be the most useful to use the formula. And you could say, well, the formula says that M equals y2 minus y1 over x2 minus x1. So you could say, well, in this case, I know that my slope is -1. And y2, I'll have be -4. So I'll have -4 minus a -3 over -1 minus whatever a is, but I don't know what a is. And if you minus a negative on the top, what's minus -3? Yep, same thing as adding 3. So you could write this as -4 plus 3 over 1 minus a. And -4 plus 3, I think I heard someone say that, is -1. So you'd get -1 over -1 minus a, and that equals this -1. And so ultimately, we want to find out what a is. We're trying to find this missing x coordinate. And so essentially, you would solve this equation for a. So since I kind of have a long version of this equation, I'll rewrite it. So I have -1 equals -1 over -1 minus a. Now, right now, a is in the denominator of a fraction. And so I want to not have it in the denominator because it's really hard to solve for numbers if the variable's in the bottom. So the way I would solve that is I would multiply both sides by -1 minus a, because that would cancel out that denominator. And now the a is not in a fraction. So -1 times 1 is 1, -1 times -a is positive a. And so I get 1 plus a equals -1. If I subtract 1 from both sides, that would tell me that a equals -2. And if I wanted to, I could graph this. So my solution basically tells me that this number should be a -2. And so I can try that out and say, well, if I go to -2, -3, and then I have the other point, -1, -4, is it reasonable that the slope between those 2 points is -1 like they told me? And it would be in that case. So that can be a good way to check your answer once you're done solving for it. So you have like one problem like that. I think there's also a problem where like you have an A here and an A here. So in that case, again, you would just do like the subtraction process, but you'll end up with a slightly different result. Let's see what else. Oh, parallel lines. So you also have some questions on your homework that involve parallel lines. So before I show you how to solve one of the problems, what do you guys notice about the relationship between all of these slopes? Yeah, they should be the same, right? Because they're all the same steepness. So they might be placed at different places on the graph, but all of the lines have the same steepness, which is the thing that slope is describing. So parallel lines will always have the same slope. So on your homework, you'll have a problem that looks like this, where it says find the slope of a line that is parallel to the line that goes through -2, 6 and 1, 3. So if I were to graph that line, -2, 6 is there, 1, 3 is here. So this is my original line that they gave me, and I need to find the slope of a line that's parallel to it. So I could draw my line anywhere, like I could say there's a parallel line, here's a parallel line, but really it doesn't actually matter where I put my parallel line, because the slope of that line is going to be the same as the slope of the line they gave me. So if I can find the slope of this red line, then that gives me the slope of any parallel line I could graph on there. So what would the slope of the red line be? Yeah. Yep, perfect. Yep, because if you wanted to, you could do rise over run, and there's 3 units here, 3 units here. Or you could also do 6 minus 3 and -2 minus 1. So I could say m equals 6 minus 3 over -2 minus 1. That would be 3 over -3, which, like you said, would equal -1. So this would be the slope of a line that would be parallel to that. Then the other thing that you might end up with is a question about perpendicular lines. So remember, perpendicular lines are ones that form a right angle with each other. So this may not be a perfectly perpendicular line, but it's a good sketch. So first of all, we know that the slope is not going to be the same because they are not the same steepness. They're not going in the same direction. So for this original line, was it positive or negative? Positive. And for our perpendicular line, that's going to be negative. So we know that the signs are going to be opposite. Then we also need to look at, well, how steep is it going to be? So if we look at the steepness of this line looks more steep than this one, right? And we could exaggerate this even further if we maybe drew another line. So let's say I have this, and let's say my original line maybe looks like this. And then if I drew a line that was perpendicular to it, hope I can eyeball this correctly. You guys see how this original line is way steeper than this line is? So on this one, our original line was negative and it's pretty steep. Its perpendicular line is positive and it's less steep. And it turns out that the steepness of the two lines are reciprocals of each other. So if we went back to this one where we have like an actual table, I could look at this one and say, okay, well, it looks like my graph goes through this point and maybe this one as well. So if I do rise over run, my rise is going to be going up 7 and my run is going to be going over 4. So the slope of my original line is 7/4, and the slope of the perpendicular line is going to be -4/7. And we could graph this by maybe just choosing some random point here. If I go down 4 and over 7, and I graph that line, sorry, there's like a lot of writing here. Let me erase the ones that aren't necessary. So if I went down 4 and over 7, you can see that this black line is perpendicular to the original one that had a slope of 7/4. Does that make sense? Okay. So to summarize, this is the slope formula. You can also think about it as rise over run, or like the change in how much like you're going up and down and the run is how much you're changing side to side. Parallel lines have the same slope, and perpendicular lines have opposite reciprocals. So if you start with a positive slope line, the perpendicular line will be negative, and then you do the reciprocal of the number. If you start with a negative, then you do a positive reciprocal. So they're opposite reciprocals. I'm trying to remember. Oh, there is one more problem that a bunch of people had questions on. I think it might be, where was it? Oh, maybe I accidentally deleted it. Okay, well, I'll do my best to remember what it was. It was something like find the slope between the points 3x, 5y, and like 7x, I don't know, 9y or something like that. So in this case, this one would not be a helpful one to do rise over run because you don't even know what the points are. You know that the x coordinate is 3 times something, but you don't know whether that x is a 1 or a 5 or a 12 or a -4. Like you don't know what x is. And so you can't really graph these because you don't know what x and y are. And so to find the slope between it, you would use the slope formula and you would say, okay, well, I can take my 2 y coordinates and subtract them. So I'll do 9y minus 5y and then divide that by the x coordinates subtracted. And that means that my rise is going to be 4 times whatever y is. I don't know what y is, but whatever it is, that's going to be how much I rise. And then my run is going to be 4x. And in this case, you could reduce that fraction to y over x. So the slope is going to be whatever number y is divided by x. But in your problem, like you might have like 5y over x or something like that. So on that one, you kind of have to use the formula because you can't, like you don't know what y and x are, so you can't graph it. And this is just what you would type into your answer. So I think that's everything. So I didn't take any screenshots of the homework problems from my XYZ because a lot of them are very picture based. So I thought it might help more if I just work with your picture specifically. So if you guys want to open up your laptops and start working on your homework, you can. And if you have any questions, let me know.